Welcome back to The Explainer, focused learners. I'm absolutely thrilled to have you here today because we're diving into something completely fascinating, the architecture of trust. We're going to explore how the literal, microscopic, physical architecture of computer chips actually dictates the multi-million-dollar strategies of modern venture capital. I know, right? It sounds crazy at first glance. Most top-tier VCs walking the halls of Sand Hill Road probably don't even know what an FPU or an ALU is. They're dealing in cap tables, term sheets, and board seats, not silicon architecture. Yet, as we're going to uncover today, these tiny hardware components are silently dictating the fate of their entire portfolios. It's a direct connection between the silicon inside your computer and the boardrooms of top investors, and it honestly changes everything about how companies will scale in the future. Okay, let's dive into this. We're taking a macro to micro to macro journey today. We'll start with number 1, the VC paradigm shift. And then number 2, the FPU gambler problem. From there, we hit number 3, the ALU surveyor solution, followed by number 4, baking in provenance. Then it's number 5, achieving metabolic efficiency. And lastly, number 6, the future of legitimacy. Trust me, this deep dive into hardware determinism is going to perfectly explain the ultimate modern business strategy. All right, section 1, the VC paradigm shift.
So let's look at the high-level business concept. Right now, venture capital is undergoing a massive fracture. It's basically splitting into two totally distinct opposing philosophies. On one side, you have the old guard, the liquidator VCs. Their entire operational model is just extracting value quickly. They treat investments like power law lottery tickets. Place hundreds of bets, hope just one or two hit big to cover the losses of the rest. In this model, founders and sometimes entire companies are kind of treated as disposable. But then on the flip side, you have legitimacy VC. This is all about world building. These investors are focused on creating sustainable, high-trust ecosystems through careful, long-term stewardship. They aren't just placing bets, they're architecting the infrastructure of the future. And here's the really critical distinction from our source material. While legitimacy VC is the broad philosophy of building trust, provenance VC is the exact, rigorous, mathematically verifiable execution of that philosophy.
Because think about it. To actually execute that provenance VC model and support a legitimacy ecosystem, you absolutely must have a reliable, mathematically perfect record of who contributed what. You need perfect provenance, an unbreakable chain of title. What happens when trust breaks down in a digital space? If an investor can't definitively prove who owns a piece of code, or a digital asset, or a fractional share, the whole thing just crumbles under lawsuits and audits, right? Without a perfect chain of title, a high-trust ecosystem is quite literally impossible. But as we dig into the tech side of things, we hit a massive roadblock. The computer systems running our entire global economy are built on a foundational layer that makes this kind of perfect trust mathematically impossible.
Which brings us to section 2, the FPU gambler problem.
Let's shrink down to the microscopic level. Meet the floating point unit, or the FPU. This is a physical component inside almost every modern computer, and it's specifically designed to approximate non-discrete math. We're talking about things like finding the square root of 2 or calculating complex geometry. To do these calculations incredibly fast, every single chip manufacturer burns proprietary seed tables directly into the silicon. So what does that mean? It means an ARM chip in your phone and an Intel chip in a server will actually give you slightly different answers to the exact same equation. Now, if you're just browsing the web, a microscopic rounding difference doesn't matter. But modern systems, especially AI agents and high-speed analytical trading engines like TurboQuant, rely heavily on this hardware. And this hidden, non-deterministic drift, it compounds wildly. Over millions of transactions, those tiny differences drift into massive financial discrepancies. You literally cannot guarantee the exact same outcome twice.
To really grasp how severe this is, check out this brilliant quote from the source material. Kyle McLean Smith puts it perfectly. It's fundamentally an approximation system, not real arithmetic. And that is exactly what the FPU is. It's basically a gambler. It's throwing darts at a dartboard, giving you a really good guess, incredibly fast. But because it's always just a guess relying on hidden proprietary hardware logic, true accountability and forensic precision are mathematically impossible. You cannot build perfect provenance on a foundation that's just guessing.
Now, what's really interesting as we move to section 3 is the ALU surveyor solution.
Fortunately, the exact antidote to this whole non-deterministic drift problem has been sitting inside our computers this entire time. If the FPU is the gambler throwing darts, the arithmetic logic unit, the ALU, is the surveyor out in the field with a precision laser. The ALU is a fully deterministic, universally consistent hardware component. It performs exact, verifiable arithmetic, absolute certainty,
1 plus 1 equals exactly 2, with absolutely no hidden seed tables or approximations. And because the ALU operates the exact same way on every single CPU on Earth, it acts as a completely reliable, globally accountable witness. For a venture capitalist, this is everything. It offers ultimate peace of mind because the hardware itself guarantees that your digital asset is exactly what it claims to be, regardless of what machine is analyzing it.
When we compare these two components directly, the implications for the future of business become crystal clear. The FPU gambler is non-deterministic, heavily reliant on secret seed tables, and while it's super fast, it's totally unaccountable. Its logic is completely isolated to one specific machine. On the flip side, the ALU surveyor is strictly deterministic and universal. It provides absolute forensic accountability. That means you can share its logic across a vast global network and every single participant gets the exact same mathematical answer every single time. It's the literal difference between building a business on a rough estimate versus building it on an undeniable, universally agreed upon fact.
Which leads us to Section 4, Baking in Provenance.
So, developers are now rewriting core system functions to intentionally use the ALU instead of the FPU, often using C language and WebAssembly. By doing this, they achieve perfect hardware determinism. This is the massive breakthrough that unlocks true provenance VC. It completely eliminates what the industry calls the mask rendering cost of narrative trust. The mask rendering cost is that massive hidden tax companies pay to verify truth. The endless legal fees, the third-party audits, the months wasted just figuring out who actually owns a piece of intellectual property. When you establish undeniable provenance hygiene by using the ALU, you're literally baking the chain of title directly into the digital substrate of the internet. You don't need lawyers to argue a narrative anymore. The system is undeniably true, because quite simply it is what it is. This completely solves the computational prisoner's dilemma by giving us true forensic accountability.
So the crucial point here is Section 5, Achieving Metabolic Efficiency. This is where the microscopic hardware shift unlocks unbelievable real-world economic growth. When you have an undeniable chain of title baked permanently into the substrates, the immense friction and financial burden of verifying trust, it just vanishes. By dropping the transaction cost of trust to near zero, the metabolic cost of doing business absolutely plummets. Because it is what it is, a startup no longer needs to hire armies of third-party auditors or compliance officers. The ALU has already proven ownership cryptographically, beyond a shadow of a doubt. The business doesn't have to pay that grueling mask rendering costs tied to non-deterministic FPUs and shaky narratives. All that energy previously wasted on proving trust can now be redirected 100% into pure growth.
Here's how that actually compounds in real time. First, companies operating in this new ecosystem support each other with absolute certainty, bound by a fully deterministic network. Second, because that trust is a literal feature of the hardware itself, corporate waste and daily metabolic costs disappear. Third, instead of just scaling linearly, the capital saved from skipping audits and legal battles feeds directly back into the mathematical exponent of the system. Which brings us to step 4, true exponential superlinear growth. It's a completely frictionless environment where efficiency drives incredible power law returns simply because the underlying math never lies.
And finally, Section 6, The Future of Legitimacy. Bringing this whole narrative full circle, we can see exactly how microscopic ALU determinism connects back to macro venture capital. Legitimacy and provenance VCs are definitively done playing the lottery. They are actively investing in first principles assets. By deliberately ditching the FPU gambler and fully embracing the deterministic truth of the ALU surveyor, these visionary investors are building networks that achieve extreme legal abundance and hyperdeflation. Legal abundance means contracts execute perfectly without friction, and hyperdeflation means the cost of software and services plummets towards zero because the verification overhead is completely gone. It's a totally new paradigm where the foundation of the digital economy is finally built on verifiable, undeniable trust.
Which leaves us with a pretty critical question to consider about our own technological foundations. Is your ecosystem built by gamblers, or is it measured by surveyors? Take a moment today to really think about what is running underneath your systems and whether you're relying on approximations or absolute truth. That's all for today's Explainer. Keep learning, keep building, and I will catch you next time.